All right. Good evening and welcome. So glad to see all of these people here tonight. I'm Susan Webster, and I'm part of the Fishing Creek Watershed Association, and we're very happy to have a room full here for this presentation. We're so pleased to have tonight, as you know, Doctors Jennifer and Christopher Whisner, who teach at Bloomsburg University. They are both associate professors of environmental, geographical, and geological sciences. Yes. And they have presented here twice before in great presentations, and we've learned so much. We're all interested in the history of our watershed, and their history goes into the way back. So please welcome Jen and Chris Whisner.
Hello, Zoom audience. All right, we didn't break down who was going to say what, so there may be some long pauses where we go at each other. So just bear with us. So for those of you who were at the earlier presentation, I think last year sometime, or about geology, rocks in the Fishing Creek watershed, some of this will be a repeat, but we're going to dive a little deeper this time into some of the, as Susan was saying, some of the old processes that went into building the landscape that we see today. And then you guys will get to have some hands-on activities where you build yourself a folded landscape. And then you erode through that landscape to see what it looks like. Maybe you can see if you can make some of the same patterns that you see on the geologic map. So I've got to figure out spacebar. There we go. Sweet. All right. So what we're going to talk about today mostly has to do, there are two different energy sources for the Earth. There's the heat inside the Earth that comes from radioactive material in the Earth's core. Well, some of it's left over from when the Earth was a melted blob of rock floating around the early sun, but there's also constantly generating new heat from some of the heavy elements like uranium that sank into the core. When they break down and decay, then they release some heat, so that generates heat that works to move rock in the mantle, and rock in the mantle helps drag around the thin crust that we walk around on right now. That's where we're on the frothy foam that rose to the top of the molten earth and has been recycled a little bit.
Apple.
You say.
So the crust of the earth, if you want to compare the earth to an apple, you have the core of an apple, and then you have the fleshy part, I guess, that you actually eat. And then the crust is basically the skin of the apple. So the skin of the apple is extremely thin compared to the rest of the apple. The skin, the place that we live and spend all of our time on, is also extremely thin compared to the rest of the planet. But we don't get to see the rest of the planet. We only get to see the very top part of this stuff.
And you can see that some of those processes that mess with the Earth's surface involve if you think of the skin on the apple, if it were broken into parts, that slow boil in the mantle moves those pieces apart. And in some cases where they're moving apart, they're slamming together with something else. So we have new crust being made, old crust being recycled, volcanoes, earthquakes, rifts, all kinds of fun stuff at the Earth's surface. And this is you.
Oh, anyway, so what we're going to talk about is these collisional events where you have some crust that's being pushed underneath other crust, which is called subduction. Where actually, as we discuss things in here, it's going to get a little more complicated than this. This is from the webcomic XKCD, where subduction is what makes mountains. And what we live in effectively is this old eroded mountain chain. It didn't form quite like this or like this. But we're going to kind of talk about what the processes are, and then how we get to see the stuff at the surface due to the processes that are sort of illustrated in this picture.
So if you saw the earlier talk, you know that the other force that creates change on Earth's surface, the other energy source is the sun. And you might think like, okay, it's the sun. Why is she showing me ice? That doesn't really make any sense. But if you think about it, the power, the energy that gets water out of the oceans and into the atmosphere where it can come down as rain and wash away our landscape as a river, or can come down as snow and pile up and ooze down over the landscape and scrape things away as a glacier, all that starts with the power of the sun. And in Pennsylvania's landscape, we don't have mountains like this. We had different kind of glaciation. We had continental glaciation. So if you think of snow building up like a giant like really slow pancake batter, so you're mounding the pancake up around Hudson Bay, and it's slowly oozing out to in all directions, including down at us. And you can see here we are in Pennsylvania, and we've got the northeast and the northwestern part of Pennsylvania were covered by continental glaciation. So that all goes back to sunlight as the energy source, moving water up into the air where it can come down. Also, freeze-thaw activity. Here
Me go. All right. So yeah, so we are going to do this handoff thing apparently every other slide. Anyway, so what you see here, this is Hickory Run State Park. This is the boulder field, and this collage of rocks and stuff actually formed due to relatively cold temperatures all year round. So this is not necessarily a modern formation. This is actually due to the last glaciation, and then after the last glaciation, you didn't have ice covering this area. There was ice that away, but you have very cold air that's constantly coming over here. Any water that was in here was freezing, and then maybe in the sun it might have thawed a little bit. And that process where you freeze water, it actually expands and gets into cracks in rocks and then breaks it apart. And so this used to be a solid layer of rock. So we'll talk a little bit about solid layers of rock eventually. But this is actually this broken up layer of rock, and then it's slowly been made into these smaller individual cobbles and boulders and that type of thing. And this also is on just a slight slope. It's like 3 degrees, something like that. And with enough water and maybe also stuff with a little bit of ice, it's actually slowly moving kind of towards us, I guess, in this picture.
And if you're feeling adventurous, if you go to Hickory Run and you go to the boulder field, we're sort of in the middle of the boulder field, but if you go to the very far side of it, from the parking lot, yes, far side from the parking lot, and you work your way back through the trees, you will see that the pieces near the parking lot are kind of small. The further you get from the parking lot, the pieces are bigger and bigger and bigger because they're younger. They broke off more recently, and they haven't actually been shattered into smaller pieces. The ones that are closer to the parking lot tend to be a lot smaller. So you can see pieces that are, I don't know, small, like a VW bug size chunks of rock.
At least for the older people, you know that. The younger people may not.
Okay.
So again, this is also another process that is modifying the landscape.
And driven by the energy of the sun. Yeah. Also streams. This is a Fishing Creek Watershed Association meeting, so we're interested in the work that streams do in the watershed, but we're not going to talk about most of that today. We're going to take a look at some of the rocks that we see in Pennsylvania, and this donut represents geologic time. So this is 4.6 billion. The G is like giga, so 4.6 GA, 4.6 billion years ago was when Earth was that floating blob of melted rock floating around the sun. And we get closer and closer to the present day as we go this direction. And you can see right in here, that's where the dinosaurs got wiped out. The width of that line is a couple million years. That's how long we've had these glaciers and interglacial periods. And then people is like an eyelash. So humans on Earth have not been around very long. So it's kind of cool to look back in time and look at, so we're going to look at some rocks that formed around 1 billion years ago. Some more rocks. Most of the rocks around here were formed somewhere between 500 and 250 million years ago. We'll talk a little bit about these more recent rocks, but not a whole heck of a lot, because especially the most recent ones aren't rocks at all. These are some of the deposits left by glaciers, but we'll have to leave those for another time. Ooh, or field trip. Field trip. All right. So in general, so here's a simplified geologic map of Pennsylvania. You can see Columbia County is circled. We're going to show you some other maps, so if you can kind of sort of memorize where this circle is, it'll be in the same place on subsequent maps. And in general, in Pennsylvania, we have older rocks down here, and the further this direction we go, we get to younger and younger and younger rocks. So up here in the northeast, or sorry, northwest, are some of the youngest rocks in Pennsylvania. Except, oh gosh, green and red.
Yeah.
Go.
So, what has happened, and we'll get into the sort of the story of this, but you have layers of rock that were deposited on top of igneous and metamorphic rocks. We'll talk about that in a while. And then those rocks have been folded in a series of events. So the folding stuff is really what we're going to talk about today. And what you see here is the purples and pinks and that type of thing. And then into the blues, you're getting younger and younger rocks over here. And then you take all this stuff, and it turns out that Africa and Europe and North America were all kind of one big continent at one time, and then they got pulled apart, and you make the Atlantic Ocean. And we actually have evidence of that pulling apart, that ripping. You actually have stretch marks on the continent here. And this area in green right here, this is the Gettysburg Basin, and then you have the Newark Basin. And these are two places where you actually rip the crust apart. You have volcanism that happens in this area. This red, this is happening 170 million years ago, something like that, 150 million years ago. So this stuff is not active now, but you have these younger rocks that actually sort of appear after all this other stuff has sort of gone by. So you have this general oldest to youngest trend, but then there's this little fly in the ointment.
And another fly is basically these are beach deposits that are on top of all of that stuff, which are younger still. So if you take a look at, so the geology is gone, the rock types are gone, and we're just looking at the landscape of Pennsylvania, and you can see, so here's where we are. We're in Columbia County, and you can see there's the British Glen is up here, and the East Branch and West Branch of Fishing Creek are up here, where Dr. Laird does a lot of his work. And you can see we've got, if you were just, if I just gave you one of these maps and said divide it up, you would probably say, there's something kind of, this all looks sort of similar, and then this all looks kind of similar, and then this all looks kind of similar, and that's because they are, and we actually have fancy names for these things. They're called physiographic provinces.
Oh, okay, sorry. So you can actually divide up the world in Pennsylvania into three sort of basic different areas that have similar landforms. So they have a similar topography. You've got this, what's called the Piedmont province, which is actually a bunch of the older rocks that are relatively low in elevation. And you don't see a whole lot of folding and stuff at the surface. And so you have lots of rolling hills and landscape. You know, this is our Amish country type of place, like Lancaster County is sort of a good generic image of what's going on there. And then you have the central area, which is the blues and stuff that we live in. And this is called the Ridge and Valley, or Valley and Ridge, depending on who's talking about stuff. And this is where you see sort of the squiggly lines. And again, this is where most of the Fishing Creek watershed exists. And then you have this other area that is not squiggly lines. It's relatively flat lying rocks in the greens and yellows and stuff. And so this is what's called the Plateau province. And each one of these areas can be subdivided, which is what you're seeing in here, but really for our story, just these sort of three broad provinces have different types of landforms, different types of shapes of the features on the surface.
So let's take a look at the oldest rocks in Pennsylvania, and those are about 1.3 billion years old. If we want to look on the geologic map, they're down here in this kind of khaki green or tan or whatever that color is. That shows you where they are. And those are there because, oh, wait a minute, show of hands, who has heard of Pangea? Excellent. So did you know there were other supercontinents before Pangea? All right, we got some nods. Those old rocks that we see that are 1.3 billion years old that we see in the southeastern part of the state were actually from a mountain building event that was caused by a supercontinent forming, all these cores and continents slamming together. And if you're wondering, this is North America, but you have to kind of look at it like this, because this is south and this is north. So our whole continent was upside, well, for us upside down. It was perfectly normal at the time, of course, but since then it's moved and it's sort of swirled around. But anyway, there was a mountain building event there. It was called the Grenville Mountain Event, Grenville Mountain Building Event. And you can actually see that's just this little strip of rocks right here. If you could pull off, maybe 1,000 or 2,000 feet of rocks across the whole continent, you can see underneath that, there are layers upon layers of mountain building events mountains formed, and then were eroded away. And we have a whole bunch of interesting, really old rocks that accumulated like layers on a jawbreaker, basically. After this mountain building event, we had rifting.
Yes. Yes, we did. Okay. So you have these mountain building events where you have two continents that are smashed together. They push rock up into the atmosphere. That's what we call mountains. And then after a time, the energy of doing that is just like two trucks running into one another, and you're seeing the crumpling up of their hoods. But then after a time, there's no more energy, so that process stops. And then the cycle of mountain building then changes into rifting, and we go through a process of actually creating oceans and stuff. And so just like we have evidence of rifting in the Triassic in the Gettysburg Basin, the Gettysburg area, and the Newark Basin, we had rifting that occurred at about 600 million years ago, 700 million years ago. We don't really see much of that on the surface, but you have this breakup of the crust, and then as you're breaking up the crust, you're actually thinning it, making it lower, and then it starts to fill with water, and then you have this process continue, and bam, all of a sudden you have an ocean. So we have what was the proto-Atlantic, I guess, in that.
And on top of those down drop blocks in the rift, so we're just seeing one half of this rift now, you get debris being shed off the continent. So river picks up, you have a big rainstorm, it picks up some sediment, it runs out into the ocean, and it drops the sediment, and it accumulates in layers. Now this is kind of bad. I'm showing you this first because what it looked like for us was really this. So that's North America. Here's the Atlantic, but I couldn't find one that faced the right direction. So please excuse things being backwards.
So the sediment, the rocks that are at the surface right now, that we're going to talk about being folded and everything else, they are layers of the sediment that was being either shed off the continent or is actually on the surface. And so as the environment changes, you have sometimes when it's kind of warm and tropical, sometimes when you actually are closer into shore, you have sand and other stuff that's there. This actually is producing these layers of rock that are at the surface.
Sorry.
Okay, that's really fine.
So this lovely layered rock is going around. It's a sandstone. You can tell it's a sandstone because you can both see and feel the grains. So pass that around. So sometimes the rocks being deposited off the shore are going to look like that. This is, did you look at the bottom of this?
Yeah, it's got like flute paths or whatever.
Okay. Anyway, there's some cool sedimentary features on the bottom on this side of this piece. This is a chunk of the Bloomsburg Formation. This is a red shale, so you can tell it's very fine grained. Basically, if you cook it, you would get slate, like you might put on the roof or have in your foyer or something like that. But this is another rock type that might have formed on that boundary.
I was going to actually say. All right. Anyway, so basically, we have given you guys now 20 minutes of precursor information to get to the point where we're saying you got these layers in here. So you guys are actually going to build these with your Play-Doh today. You're going to build layers, and then you take the stuff, and it's just sitting here, sort of they're becoming rocks and sort of perfectly happy. And then you're going to have Africa/Europe come in and smash all this stuff again to get, again, the patterns that you see on the maps in front of you or the map over there.
Chris found another rock type that might form on especially this beautiful, shallow, clear, warm water is limestone. If you go down to the Florida Keys and you go not on the Atlantic or Gulf of Mexico side, but sort of between the Keys and Florida, you'll see some beautiful fine grained limestone. So this has some marvelous fossils in it. So this also is another rock type that might be deposited out there in the ocean, and that would later get folded up. So most of the rocks we see around here formed in the Paleozoic. So again, that's from about 540 million years ago to maybe 250 million years ago. And it's been busy on the East Coast. We have about 440 million years ago, we had a volcanic arc. Oh, thank you. But you should talk about this.
So we've had multiple mountain building events after the Grenville, which happened about 1.3 billion years ago. We have the Tectonic, which happened in the Ordovician, which was about 500 to about 480 million years ago, so a long time ago. We actually have that continental shelf that we showed you guys that had all the rifting and everything, and then all those sediments. And then you actually have this subduction. So we wanted to bring that up earlier, and this area of volcanoes. So think about like Japan, or the Philippines, or some sort of island, smaller island thing. This isn't a full-on continent running into us, but this thing smashes up against North America, takes all these sediments and mixes them all up, basically heats them up and also pressurizes them. And then this stuff all gets thrown up onto the continent as well. No, that's good. So anyway, so this is all happening down here. So if you go into this area down here, you actually are seeing sediment that has been smashed by this incoming volcanic island chain, effectively smashing into the continent, and actually changes these things into metamorphic rocks, which the other Dr. Whisner is showing you right now.
Beautiful, nice, a nice. And if you have, there's slate down there, there's Chickees rock, there's quartzite down there, there's all kinds of fun metamorphic rocks in that area. We also had another plate collision.
Yep. So this is sorry, if you want.
So you do that one.
Anyway, so about 390 million years ago. So we're just talking about 480 million years ago. You have the tectonic orogeny, and then the continent sits around for a while. Things happen. Basically, you have those tectonic mountains erode away, and then especially in the Northeast, from about Pennsylvania north up into New England and into Canada, you actually have another small continent. So think something the size of Madagascar. Everybody knows what the size of Madagascar. Okay, you can all picture it, I'm sure. All right. So if not, it's think about something like the size of Texas or Florida running into us. And this also produces another mountain belt or mountain building event. And also what this ends up doing is you have material that's actually being, sorry, Katie for the base. You have material that's actually, no, it's being thrown this direction. This is flipped around from, it's okay. But anyway, you have material that's being sloughed off of this that actually makes piles more sediment on top of us about 390 million years ago to create.
And the weight of that makes the crust kind of sink. Having all that debris piled on top of it makes it sink down. And when it makes a basin, and the first thing that flows into the basin is a lot of organic material and fine grained stuff, and that is where the Marcellus Shale comes from. So if you're wondering why on earth do we have oil and gas here in Pennsylvania, it's because we got a little continent slammed onto the side of North America, warped the crust down a little bit, made a low spot that filled in with, among other things, the Marcellus Shale. And that was, so at the time that this was happening, there would have been mountains here. Oh, a lot of the rocks around here, the Catskill. And if you think about the Catskills, that area, it is actually made of rock that got shed off, sediment that got shed off those mountains. So during all of these, we sort of have a snowplow effect. Oh, I don't know if you've ever noticed it, especially when it's like a nice sort of wet snow. I'm not much of one for like flinging the snow. I like to push it off to the sides because otherwise it hurt my back. Anyway, you might have noticed that it sort of slides along for a while and then you get a piece that kind of kicks up, and then you keep going and it slides along for a while, another piece kicks up. That's exactly what's going on with the rocks when continents slam together. Except, of course, in the eastern US, the snowplow would be going the other way. So our last mountain building event was Pangea that everybody pretty much knew about. I love this diagram because it actually shows where countries and where the countries are. So here we are in the United States, and we're slamming into getting crunched against North Africa. If you want to know what it probably looked like, there's a fellow who does some pretty cool reconstructions. So here we are. Replace this with North America. So North America is kind of rotated this way. And we've got this mountain building event all along the edge. And if you've ever wondered where, like you might have heard about, if you go visit the Carolinas and go to the coast, or even the coast of Pennsylvania, you hear about the Piedmont. The Piedmont is sort of the squishy center of the mountains that build up. And then way the heck out here is where we are right now. This is the snowplow where we're forming these bent up.
Oh, it's working.
Okay, so here is the snowplow in action. Picture that giant bump on the right as an island arc or a little continent or possibly Africa, and picture all those layers as the sedimentary rocks, the sediments that got draped over that rifted margin of the continent. I think this keeps going.
It does.
Okay. Just like shoveling snow.
Except it's getting really heavy, right? So
Yeah.
it becomes harder and harder to push as you pile more and more stuff on here. And so what's happening is the material is actually breaking through, and you have these faults that propagate into the undeformed stuff. And so they do a fantastic job showing this thing.
These are the mountains that we.
Yep. So what you're seeing is the surface stuff, and then you got all the stuff that's internal to them, and then eventually what's going to happen in our sort of story of time, eventually the surface here will erode away, and then we start to see all the squiggly.
All right. So what we are going to make is we're going to get to play a little bit with some Play-Doh and make some flat layers and then deform them, and then we're going to erode through those layers. We have high-tech devices such as dental floss and plastic cutlery to work with. But you can make a landscape that looks like Pennsylvania, where we have these layers that you see repeated that were originally flat layers, get folded up. Some of them stick up in the air. The tough rocks like sandstones and conglomerates end up sticking up in the air, things like Catawissa Mountain and Knob Mountain. And things that are soft like limestones and shales tend to get eroded away, and they make low spots in the landscape.
Like Fishing Creek,
like Fishing Creek. And the Susquehanna follows some softer rocks. And if you made a slice through it, this is the beauty. You guys are going to you can do this tonight. These soft rocks are lows, the tough rocks stick up, and so we have valleys and ridges.
And then there's a side view right here.
Yeah.
So top view, side view.
And again, my apologies to those who were here for the other presentation, but a good example of this in the landscape. So this is a picture taken from the stands at the university in the football stadium, looking towards Danville. So we're looking off towards Danville, and you can see where this little bitty ridge right here is the same layer that is actually over here on the other side of the valley. So that was what if you're standing anywhere around here, if you're standing, look up and think of the massive rock that was over your head that is now gone. It's been eroded away by ice and water and dumped into the Atlantic. So right now what we see, if you erode that layer away, So that's gone. We just have a little bit of it sticking up. Now, nature is working on this next layer down, which is the,
So that is the Rose Hill Formation, which you can actually see if you take Railroad Street and go through along Fishing Creek, especially on the west side. You can actually drive through this and see the layers that are tilted in one direction on the south side of this, and then as you drive from Fernville all the way across, and then get to the little, what is it, the sort of triangular little intersection right there. You take a left to go to Walmart, you take a right, you can go to was Ken's Cattails or whatever. You actually see the rocks on the other side of this fold.
so when you see a landscape that looks like this, you're like, oh yeah, there's some flat stuff and there's some stuff that sticks up. If the stuff that sticks up is sticking up because it is a particular rock type. So those same rocks that stick up,
Are represented by similar colors.
oh yeah, sorry, the colors represent different layers. And so the same rocks that are pretty tough and stick up here, up around Wilkes-Barre and Nanticoke, are the same things that stick up and look tall down here around Catawissa, which are the same things that are tough and stick up in the air around Big Mountain and Little Mountain near Orestes and Ashland and Centralia. It's that same layer. It sort of went up in the air and it disappears, and it comes down and we see it again. And it's been eroded away and it comes down and we see it again.
So it's even the same stuff that you see up here on the plateau as well. So these high elevation areas are due to the same rock types sort of appearing and then being eroded away, and you start to see other stuff below them, and then you're seeing these same rock types again, repeated over and over and over.